Hello, we are the Stamp for Success team, a group of UW-Madison students in the InterEgr 170 class, tasked with creating an automatic stamping device for students with motor disabilities. Our client, Sue Schmidt, works with the Madison Metropolitan School District, and she instructs students with motor disabilities who use stamps to sign their work and to create art. She noticed that many students are not able to apply the downward force onto a stamp, and they require a device to do it for them. Since there is no such device on the market, our team was tasked to create one, and it came with certain requirements. First, it would have to be battery operated and connect to a switch. It would also need to adapt to many different sizes and types of stamps, along with being light enough for a teacher aide to move it between desks in a classroom.
When brainstorming, our team focused on 3 preliminary designs: an arm mechanism, a spring box, and a piston and frame. For the arm mechanism, the base could be mounted to any chair that has an armrest, such as a student's wheelchair. From that base, there's a telescoping arm with a hinge that rotates to press the stamp down. These movements will be powered by a servo that moves the gear and chain to move the pulley system, which allows the arm to complete the stamping process. We decided against this design because it would be difficult to position and would require more assistance from the teacher aide. It also had the highest estimated price, being $80.
The box will include a frame that will be placed around the stamp. An interior moving plate will be attached to the end of the springs that will provide force. The motor winds up a string, compresses the springs, and leads to the stamp being pressed. We decided against this design because though it had a lower estimate price of $75, spring forces can be unreliable, and we aim to make a highly effective product.
For our final design idea, we decided to move forward with the piston frame design, in which a frame will go around the stamp while all the other components are attached to the frame. One end of the piston would be attached to the top of the frame using bolts and a 3D printed bracket, and the stamping end would have a 3D printed plate attached to it using a bolt. When the switch is activated, the piston will move the plate down and push the top of the stamp down. The resulting force of the piston pushing on the stamp will leave an image on the page. We settled on the piston and frame design for 3 main reasons: its effectiveness, ease of use, and reliable applied force. In addition, it had the lowest estimated cost of $70, which provided us with plenty of room in our $100 budget.
The creation of our product occurred in 2 parts, with our group split into 2 groups: 3D printing and laser cutting the frame and its components, and electronics and programming work. Our CAD team created a model of the frame using Onshape, with the prototype being cut from wood. The attachment piece and moving plate were also designed on Onshape and then printed using PLA.
For the electronics component, an Arduino Nano was chosen as our computer because of its small size that would allow our device to be as compact as possible. Paired with a motor driver and breadboard, we were able to code the Arduino to extend and retract the piston just by tapping the switch. Since adjustability was a key priority, the code uses voltage measurements to control the piston's extension for different stamps. When the piston fully presses a stamp, the motor demands more current to continue pushing, which in turn raises the voltage. The Arduino monitors this voltage, and once it reaches a defined threshold, stops the piston from extending. It then pauses briefly to allow the ink to transfer onto the paper before retracting the piston to its starting position.
This video will demonstrate how a stamping device works. First, to point out, here is the laser cut polycarbonate frame, and then here are the 3D printed parts out of PLA. Now first, the machine will have to be turned on using this switch. So this is off and then this is on. Then positioning it with the paper, this is the switch that will be tapped to cause the motion. And then with any size stamp, we're able to place it under. And with only one tap, the piston extends and then retracts, leaving a stamp on the paper.